Hello students, in this video we are going to see now Markov chains. So in the same 13th edition introduction to management science book by Anderson, you will find Markov chains in chapter Markov processes in chapter 16. So here we are going to see two types of problems. First is with respect to the market share analysis, and second with respect to the account receivable analysis, right? We'll just start with market share analysis first, but there are many other applications for of Markov chains in different fields. uh, One of such example is given here, where US General Accounting Office uses this Markov chain principle, to understand, to estimate the number of uh, the percentage of their population above 65, right? What will be their health condition in coming future? And they usually classify them into the three groups. First is the best, which are able to perform daily activities without assistance. Next best, able to perform some daily activities without assistance. And worst is they are unable to perform daily activities without assistance. So they basically require this data so that they can do their budget for the coming years. So just go through this caselet, small caselet, to understand how Markov chain or Markov process helps them to arrive at those percentages. We will start understanding the Markov chain calculations using this small example of market share analysis. Consider a small place where there are two sort of supermarkets. One is Murphy Food Liner and the other is Ashley Supermarket. So basically there are two competitors in a market, and the customers have choice to go to either one. And usually if you see here, they are assuming that the customers week use to visit these supermarkets weekly once. So during their weekends, they usually visit these supermarkets for their weekly needs. Now we will start by understanding this. See, one thing is there is that whenever there is a market competition, the organizations employ two types of strategies. The first one is called as the customer retention strategy, where they will be using some schemes like loyalty schemes, etc., where their existing customers who are buying with them are coming to their supermarkets or buying their products regularly, they will get more discounts. So that is loyalty points. So that is one. The second is the strategy where you try to attract or try to snatch customers from your competitors. So there you may be offering them first time discount, or some other schemes like that, where you will attract their customers, so the competitors customers to your customers. And in the similar manner, the competitor must be also doing this type of strategies. One, to retain their own customers to themselves, and secondly, to snatch your customers to them. And this particular dynamics in the market results into what we call, it is called as transitions. Your customer becoming their customer becoming your customer, like that. So basically transitions, and this, there are probabilities involved in these transitions based on the strategies, how strong are the strategies. So these are called as transitional probabilities. For example, if you look at this particular example, uh, this is the transition probability which are mentioned here. For Murphy Food Liner, uh, the next weekly shopping period, 90% of the customers will repeat they will again go to Murphy food ladder. Whereas there is a 10% chance that they will change and go to Ashley supermarket. Whereas for Ashley supermarket, there is 80% chance that they will again go to Ashley in the next week cycle, but there is a 20% chance that they will go to Murphy. So this will keep on happening over weekly cycles. So these probabilities will be used, and if the strategies are constant or there are no major changes in the strategies, we will assume that this transition matrix remains there, active for week after week. If the organizations change their strategies, then this particular transition matrix will also undergo a change, right? So this particular transition matrix can be also shown like this: 0.9, 0.1, 0.2, 0.8. Now there are 2-3 different ways in which we can solve the problem. What is our aim? Our aim is to find out what will be the market share of Murphy or Ashley after 3 or 4 or 5 weekly shopping cycles, or what will be the final steady state market share of Murphy as well as Ashley, in weeks to come, right? So basically, we are going to do this using different ways. First way is to use a decision tree, or basically not exactly decision tree, a tree diagram. We should not call it a decision tree; it's a tree diagram, and I will explain you this how it goes. For example, right now the customer is a Murphy customer in week 0, right, starting. Then because of this transition matrix active, Murphy will remain with Murphy for 90% of time and will go to Ashley 10% of time. So in the first week there are 0.9 probability I have to put on this branch, where he will again go back to Murphy, and 0.1 probability I have to put here, where he will go to Ashley. Now again from week 1 to week 2, because this is a Murphy's customer, again in the week 1, again we have to have 2 branches with 0.9 and 0.1 going to Murphy, going to Ashley. And here also again for Ashley there will be 0.2 and 0.8, right? 0.2 to Murphy and 0.8 to Ashley, because he is a customer of Ashley, the second one will become this particular 0.2 and 0.8 will be the probabilities in action. Now if you look at this, after the 2 periods, what will be the Murphy's cumulative probability. So you have to add the Murphy one, that is, this is going to be Murphy 0.81 and this one 0.02, so it will be 0.83, right? So Murphy's cumulative probability will become 0.83, whereas the Ashley's cumulative probability, I put it here, Ashley's cumulative probability will be, obviously add the other two, and you will see that it will be 0.17, because it has to finally the two has to add to 1. So 0.83 and 0.17. So if you add 0.09 and 0.08, you will also get 0.17. So this is how, using the decision tree, we will be able to calculate the week after week what will be the total probability, where when the starting person starting week he is a Murphy's customer, what is the probability he will be still remaining a Murphy customer after so many weeks of transition. But what happens is that when you want to do this for over 5 weeks or 6 weeks, the tree becomes larger and larger and larger, and it is not a very good way of solving it. So to avoid this, we will be using matrix. So the matrix method I will explain in my next video. Thank you.